Good morning, everybody. Welcome to, or good afternoon, depends on where you are. Welcome to NTWC Plus. It is October the 23rd. Good to have you along. We're on an hour late today, but we're here nonetheless, and thank you for joining us. And if you're watching recording, we're on whatever is convenient for you. Good to have you along today. Dr. Jason Sippel is our guest today. We'll get to him from the Hurricane Research Division in just a moment. But before we do that, we have to thank the sponsors who make this program a possibility week in and week out. We start with USAA. They have been huge in what we do at NTWC Plus and the National Tropical Weather Conference from day one. They've been supporters of the Storm Science Network and everything we do. So thank you to USAA. The South Padre Island Convention and Visitors Bureau once again in for the 2025 National Tropical Weather Conference, which will be in April on South Padre Island. We'll be here. They're with us, and we hope you'll join us as well in person on South Padre Island at the beautiful Marriott Courtyard Hotel. The Weather Company, Weather Boy, and Weather Call, all part of this program each and every week, and we appreciate all of them for being part of what we're doing, trying to keep the ball rolling here and just keep people aware, even as we get close to the end of the hurricane season. It ain't over till it's over, as they say. Hal Needham, Dr. Hal, Hurricane Hal's with us this morning from beautiful Galveston. I'm on South Padre. You're in Galveston. I think we have the Texas coast covered. Good morning, Hal.
Good morning, Tim. How are you doing? Just got back from the Hurricane Helene and Milton disaster zones. Excited to be back along the upper Texas coast where we're enjoying some beautiful weather here.
It's good to have you back, and I'm anxious to hear and see what you did while you were there. We may do that next week and kind of go through some of your photos, because I think that's just hearing your story is fascinating. So I can't wait to hear what you saw and what you learned. Bill Reed's not with us today. I think he had a tea time at 11 or something. I'm not sure, but he's out doing something today that took precedence over what we're doing. I can't understand how that can happen, but he'll be with me next week. So I think it's going to be a great program, Hal. You got Dr. Sippel's intro, so let's do that and let's get right to it, because it's been an interesting last few weeks. After everybody said a month ago, what happened? And now they're saying, oh my God, what happened? So take it away, Hal.
Yeah, y'all are going to be excited by today's guest. We have a great show for you today. Dr. Jason Sippel is his research focuses on improving operational hurricane forecasts through improved data assimilation. This covers a wide variety of topics, ranging from improving the efficiency of the hurricane reconnaissance program to assisting with the development of more advanced data assimilation techniques in NOAA's operational hurricane models. He also helps evaluate the impacts of assimilating new observations that are not currently in the operational data stream. Dr. Sippel also co-leads the Hurricane and Ocean Testbed, or HOT, at the National Hurricane Center. The mission of the HOT is to transfer new technology, research results, and observational advances more rapidly and smoothly into operations. One of his major focuses is leading HOT to improve the use and understanding of reconnaissance observations, so the National Hurricane Center can better assess tropical cyclone intensity and structure in real time. Dr. Jason Sippel, thank you so much for joining us today on NTWC Plus.
Thank you. Thank you. Good to be here.
Dr. Sippel, I mean, a lot of people have been busy in the hurricane community, but I know for you doing these crucial roles, the last month has to have been incredibly very busy for you in all the work you're doing, right?
Right. Yeah. So one of the things that I didn't get to you in my bio was that I'm now deputy director of the Hurricane Field Program that we run out of the Hurricane Research Division, which is where I work at our lab. And so, what the field program does is we basically coordinate between the Hurricane Center, between Aircraft Operations Center, and various entities at NOAA to make sure the flights get into the hurricanes, the P3s and the G4. We're the behind the scenes gears that make all this happen. And we gather the data from inside the storm and we send it out to the Hurricane Center. We send it out to the modeling center to get ingested into the models. That's what data assimilation means, is ingesting all that data into the models. And so I'm, one of the key people now in organizing that effort. And so, yeah, I'm usually pretty busy, but it's been on warp speed now because, managing all of this on a pretty small staff is tough.
Jason, when you mentioned helping to coordinate the data assimilation, are you even involved in helping plan the mission, or does someone else? I kind of want to walk step by step with this. Just there's a tropical disturbance out there, or a tropical storm. This mission needs to be planned. Are you involved in that aspect, or more
Absolutely.
once it gets up in the air?
So historically, I've been involved in, the data assimilation going back 10 years ago. I was helping to get the data more and more into the models. That caught fire. The Hurricane Center loves it now. They get the data, a lot of this data real time more than they did in the past. And so now, in addition to that, I've been more involved in the flight planning. So we will have meetings ahead of time. As we see a disturbance, as the chances go up, the disturbance is going to form. We start having meetings with the Hurricane Center days ahead of time. It takes a lot of effort to get everybody in line. We work with the Aircraft Operations Center to get their flight crews in line, to get our science crews in line, to make sure we have people on schedule to either forward deploy down to Barbados or to St. Croix or wherever we need to go. Maybe it's flights out of Lakeland, Florida, right? That's near Orlando. So we have all this planning that happens on the front end of this. And then once we start flying, then we have people on the plane manning, crewing the missions. We have people on the ground making sure that the data comes off the plane right, that we actually have ground processing that happens where, and I have some slides I'll show you, that we actually process. I can, from right here, from my living room, I have my kitchen and dining room. I process data coming off the planes and then send it out to the world, send it out to the Hurricane Center, send it out to the Environmental Modeling Center, and they also websites that people like to use, like Tropical Tidbits. They get this data, right? So this is all done internally by us. We're the link that makes the data come off the plane and get out to the world.
Jason, we're excited to hear more about that process and to see your slides. Before we get there, though, one more question. I'm curious, when all these people are coming together to decide if and when a Hurricane Hunter plane is going to fly into a hurricane, what are the criteria used to decide if we send a plane into a certain disturbance?
That's a really good question. Ideally, you can send it into any disturbance that is potentially going to have any impact on land, right? But you have limitations. You have crewing limitations. We're a small organization. You have financial limitations. Everybody's got to live by a budget, right? And so you have to decide, is this disturbance worth this extra effort? Is the potential impact? And now we're getting to a point where the models most of the time give us a hint. Okay, is this particular disturbance? Is the environment pretty good? Is it likely to intensify? Every now and then you have one that's a miss, right? Like the O storm that we just had, Oscar, right? That was a swing and a miss by the models. The forecasts were terrible. And so we didn't go into that one. Unfortunately, it wasn't, it hit Cuba as a hurricane, but it wasn't, cataclysmic, right? Most of these, cataclysmic storms, if we have a pretty good signal in the models. And so we were able to plan ahead of time and get the planes in to add that extra level of accuracy to, okay, where is this thing going to make landfall and how strong is it going to be, so that people on shore can plan appropriately.
That's fantastic. Jason, we're excited to see your slides. I know you prepared a bunch of visuals and just walking us through this process. I know it's quite complex, but you have a great style of communicating, and we're excited to see what you can present today.
Fantastic, thanks. Yeah, if you have any other questions, ask now, or we can boot up the slides.
Tim, do you have any questions right now, or should we go right to the slides, you think?
Now let's get to the slides. I'm anxious to see what you've got. Let's do it.
All right, they're up.
Okay, fantastic. So we have two portions, let's say, of the field program. There's this research component, which is advancing the prediction of hurricanes experiment, AFEX, which is more focused on the research. And then there's this operational component. I'll talk about both, but they're all encompassed generally within the NOAA's Hurricane Field Program. And I'm one of the leaders of it this year, and likely to be the director of it next year. So I'm going to be working an awful lot more next hurricane season if we have the same number of storms. You can go to the next slide. So in terms of people, we're small. We have in total about 25 scientists involved in the entire effort. But I would say of those 25, I think 15 are very active. The remaining 10 come in and out, occasionally. So the vast majority of the effort is focused on 15 people for what can be, when we're doing operations, round the clock. Be pretty challenging. I see I'm not quite centered in the frame here. So we offer a variety of support. We do crewing and ground-based support. We have experiments, right, on the research side. We have principal investigators that we work with. A lot of these operational flights we wind up doing research on the missions. So we will work with principal investigators to get research done at the end of the flight, in addition to making sure the Hurricane Center gets what they need. We do a lot of work with modeling and assimilation. Can you go back a slide? Yeah, we have map discussions every day during season at 12:30. I'll talk a little bit more about the schedule. We try to interact well with social media, and I want to hit a point that this is a marathon. This isn't a sprint. So we're operating generally between July and October. We just ended our map discussions last week, but if a storm should happen next week, we'll have ad hoc operations as needed. And then there's this real key part at the bottom: flexibility, research versus operations. So this season, 10% of our flights were pure research flights. The other 90% were tasked by the Hurricane Center for operations. And then on a given operational flight, I'd say at least 90% of the effort is towards getting NHC what they needs, and maybe the remaining 5 to 10% is of the flight time is add-on research, as we have time. Sometimes that's doing a particular experiment that just happens to align well with the flight pattern NHC has. Go on to the next one. So here's an example of the research plan. This would have been from last year, but we have all these experiments lined up, and it doesn't matter that you can't read them all necessarily. It just know that we have an awful lot of research going on as well, and we fit it in as we can. And it's divided generally through the stages of a tropical cyclone, starting from the genesis, moving to the early and mature stages, end stage. We focus a lot on ocean observations now. We increasingly are working with the oceanography division at our lab, as well as outside institutions to get better observations of the ocean, because observations in the ocean are very much lacking. And it turns out the ocean is a really important part of getting the hurricane forecast right. So we want to, improve that. We want to improve our understanding of the ocean. So that, that's a big part of what we do. And then we do satellite validation as well. So we want to understand what the satellite observations are showing us. And so we work with NESDIS, which is the satellite arm of NOAA, to understand better what the satellites are telling us. And it turns out that understanding better what the satellites are telling us can actually help us better understand what our own instruments on the plane are telling us. So there's this back and forth that's very synergistic. So it's important to do a lot of these additional efforts as we can during these missions. Okay, the next slide. So here's what our daily schedule looks like, is at least officially. So a lot of times you're up at 6 a.m. before, sending text messages and making calls, but formally we have a 9 o'clock science coordination call that bleeds right into 9:20, where we tag up with the Hurricane Center and the Aircraft Operations Center to do our planning to make sure we're all on the same page in terms of what the flights are going to look like the current day, the next day, and then a few days out. We have a daily map discussion at the Hurricane Research Division of AOML at 12:30, and those are public. Everybody, anybody's invited to those. And then we, at 1 o'clock, we have a go, no go for the following day's missions. And then we just have some graphics down here that kind of shows you what we do. We use NASA's Mission Tools Suite. I'll talk a little bit about that more. And we have this integrated observing systems from the planes up in the atmosphere down to below the ocean. We care about it all. And it gives us really an integrated view of the tropical cyclone. This little graphic on the right shows, how we are able to provide, a CAT scan of the storm that no other organization in the world can really give, especially, when you don't have satellites. I'm sorry, even though you have satellites, they can't really give you the kind of views of the storm that we get. And we'll talk about that more coming up in the future slides. Go on to the next one. So here's what 2024 looked like. So we had 7 systems were flown. A lot of collaborations across NOAA, the Office of Naval Research, University of Washington, Scripps, great ocean oceanography work being done there with our partners. In terms of missions flown, we had 45 P3 missions, 17 G4 missions, flight hours over 600. That's a lot of time in the air. In terms of operational support, I really want to hit on this, right? So remember, we have 15 really active people, mainly within HRD, our Hurricane Research Division, working on this. A few other people in our lab help out as well. 2,500 hours of operational support. So that's 62 weeks of operational support, really crammed between Beryl and Milton. That's when all that happened. So certain people are working hundreds of hours, to support other people, 50 to 100, but it's a lot. I'll give my example from Milton that I told y'all just before the show started. My pay period started on Sunday, and by Tuesday afternoon with Milton, I had worked 32 hours, I think. It's just exhausting. And our director had worked even more, right? He was pulling like 18-hour days. So it can get really, really crazy. In terms of the observations, we dropped over 1,300 dropsondes, ocean observations, AXBTs. Those are certain, they go and measure the structure of the ocean underneath. 70 of those, sent a lot of Doppler radar analyses to the Hurricane Center and to EMC to be ingested in the models. And we do some cool stuff too, right? So, I mean, all that's cool, but some really cutting edge stuff. So we released these uncrewed drones through a chute, the same chute that the dropsondes go out of, right? We release these drones, and they're all folded up in this tube, and they come out and they unfold, and then we can control the drones, and they fly right down near the ocean surface. And so this is cutting edge stuff that we can release these instruments that we control that in areas that we can't fly, right? And so they're giving us these observations in areas where we can't otherwise gather observations. And we have a lot of other observations. We have wave and observations that can measure the characteristics of the waves, which is really important when you get into better understanding in a coupled modeling sense, meaning like if you have a model of the atmosphere that predicts a hurricane, it's better that you can also account for what's going on in the ocean, including the waves. So these instruments help us to get there. And so we've had a lot of successes, our collaborations with various institutions, operational support. What we're doing has a big impact on the model forecast. It can, for example, for tropical storms, on average, we're improving the intensity forecast by, I'd say, 20 to 30%. That's a big improvement. We can better, because of our work, because we're in these storms, we can better identify which storms are more likely to rapidly intensify and by how much, which is really important. If you have a tropical storm out in the Gulf and it's going to be a Category 4 in 3 days, you want to be able to warn people, right? And these aircraft observations definitely help a lot in being able to warn the appropriate people by the appropriate amount. So we're also, as I mentioned, we're testing new technology. It's really important. So, all of this stuff is fantastic successes. Challenges. We have, again, I mentioned 15 really active people. We're doing international travel. We're a lot of times we're forward deployed to St. Croix, Barbados, sometimes Bermuda. We're doing support from these remote locations, which takes a great deal of effort to get out ahead of the storms in a good amount of time. And we're doing this almost round the clock operational support on a very limited staff. And it wears you out really quickly, right? So you're always ready for a break. And so, this is a challenge we're actually trying to get these operational flights transitioned to the Weather Service and the Aircraft Operations Center so that they can be doing a lot of the work that we're doing. And NOAA management, it has their attention, and we're working with them to kind of move this forward. But this is kind of the next step in this in this effort.
Jason, I had a quick question. I love when you talked about that you can actually conduct new research during a flight, which is fascinating to me. And you mentioned all these different, like understanding the boundary layer and really at that interface of the ocean and the hurricane and how we don't know that much about it and we need to know more. I had a question. Let's say a university professor who studies hurricanes gets a grant, federal grant, and they can actually deploy an instrument on a Hurricane Hunter plane to take measurements. How would that work? Like with installing those instruments, like would that kind of thing happen in the off season and then like on every flight of the next season, you would have that new technology? Or do you ever make those adjustments like during the season?
There's a lot of planning that goes before the season, so that you know well ahead of time. We work with AOC, the Aircraft Operations Center, to let them know, okay, here's what we have in mind in terms of the potential instruments. And we will have universities collaborate with us on the federal side to plan out, okay, what are we going to put on the planes? And there are definitely new instruments that make it on from time to time. And it is possible that an instrument will be on for only half the season. So these things, all this planning for this happens in the off season well ahead of time, and we have it all nailed down and planned out, so we're not, doing things ad hoc during the season.
That makes sense. It sounds like you really have a long-term vision of what you want to do maybe for this upcoming season up ahead.
Yeah, our work doesn't end at the last hurricane of the season. Once you go into off season, okay, you're not going, at warp speed anymore, but there's an awful lot of planning going on to make sure that you are lined up appropriately for the next hurricane season, to make sure you got all your ducks in a row.
Jason, I want to ask too, with all these different organizations, all these different personnel, all this emerging technology, I mean, it's just so many different moving parts. What are the main challenges you face to do this job well?
Honestly, the biggest challenge for us has been the operational support, just because it takes up so much of our time. It's something that it's funny. Like I'm the guilty party in this, right? When I was working over at the Environmental Modeling Center, and I was bringing this data into the models and evaluating its tremendous positive impact. And I pushed this and I pushed this and I pushed this on the Hurricane Center, and it caught fire and they loved it. And so they started tasking more and more of these missions. We fly 50 to 60% more than we did 10 years ago. And it's because of this, because it's caught fire, because NHC loves to have this data now, because they get this better evaluation of what's going on inside the storm, and it improves the model forecast. So now the challenge is, okay, we have all these additional flights, but we don't have necessarily within our division, which is really a research division, the capacity to continue staffing this mission. And so we're really trying to, the challenge is, okay, transferring this, making a research to operations transition so that other parts of NOAA can absorb this. And we're trying to make it easier. We're doing work kind of in the background to automate some of it, and also to streamline it so that they can better take on what we're doing.
So when you say operational support, you mean this has been very successful, the NHC loves it, but it's just having the resources and the staff to keep all of these flights coordinated and keep the data assimilated, right?
Yeah, and to keep the data coming off the planes, absolutely. It is a typical mission, like processing dropsondes of the Doppler radar data. It's 7 hours. You can do it. It is easier now than it used to be, because we used to have to do it from the plane. But now a lot of this can be done from the ground. And that's kind of key in this transition effort. If you can do it from the ground, that's the first step in getting to a place where, okay, some other part of NOAA can do it. But it's 7 hours of my workday, in addition to whatever else I have to do, I'm dedicated to processing dropsondes or to making sure that the Doppler radar data gets off.
Jason, yeah. Is it substantially harder for your office if we have 2 or 3 active storms at the same time?
So we only have 2 P3s. So typically we're not on different storms at the same time. So if there's an active storm, we typically have both P3s on it, or if one P3 is down, then we will actually double crew it. So we'll have an AM and a PM mission. So having multiple active storms, is challenging from the perspective of the Hurricane Center, because they have resources spread thin in terms of, okay, where are we going to put what plane, right? The Air Force has the potential. They have, I think they have 9 or 12 planes. So they have more planes, they have more crews, they can go to different storms. But at some point your resources are exhausted. So you got to kind of make a priority decision. Okay, what storm are we going to put what on? But from our division, it usually, if there's 3 active storms, it's going to be the same as if there's one, big storm. We're going to be doing the same amount of work.
Jason, what kind of technological advances can you do in the off season to help, when we get June through October-ish to help that be more efficient for next year. Are there updates to the supercomputers? Are there ways that we can do things in the off season to make it more efficient
Yeah,
when
so
things get really busy?
absolutely. So there's a project actually funded by NOAA right now to to help automate some of the processing of the Doppler radar data. So, all of this data has to be cleaned up, right? You can't just use it as it is, as the instrument sees it, right? So we have actually a machine learning automation, a tool, a project that's developing machine learning to quality control the Doppler radar data. And that is going to be really important going into the future for the next generation efforts for automation of the quality control of the data, but also when, NOAA's moving from the P3s to C-130s around 2030, right? They're going to have different radars, right? So this tool that's being developed is going to make it easier to move to the next radar, to quality control whatever we have coming next, right? So there's all these projects going on in the background to make this easier. There's also updates to the dropsonde processing software. I'll step through the dropsonde processing software looks like in a little bit, but there's always updates going on in the off season of various forms and fashions to kind of try to incrementally step us forward.
Now that makes a lot of sense. We're excited to hear more about the dropsondes, but Tim, I wanted to pass the mic over to you. Do you have any questions or have any questions come in from online yet?
We've got some good questions from online, and this is just fascinating. I'm enjoying just sitting back and listening, and some amazing stuff. All the data that's coming in, what's that process to get so much data into those models so quickly? What is that process?
So this is actually interesting. There's very few places, there's very few people in the world that have been involved in the entire process from collecting the observation, right, to processing it, quality controlling it, to sending it off to be ingested into the models or to the hurricane center, right? Most of this is all automated. It's in the hurricane environment is really one of the only places I think that where you have hands-on with all of this gathering of the observations to getting it to the model. So, in terms of the process, a dropsonde is the most hands-on. We actually have the instrument, the dropsonde. We have somebody on the plane putting the dropsonde in the chute, releasing it, comes out, parachute comes out, it takes observations on the way down. Then I or somebody else is either on the plane or on the ground looking at the dropsonde data, running it through this program called Aspen, quality controlling it, making sure that it looks legitimate. And then once we're satisfied with it, we send it out in a format that others can use, specifically the Hurricane Center or an Environmental Modeling Center, that we send it through a web interface, that whatever interface gets it to the people that need to have it. A similar process it goes on with the Doppler radar data. It's not quite as hands-on. You're just running programs on it, making sure that those programs are properly executing, but you also got to monitor the Doppler radar on the plane to make sure that there's nothing squirrely going on, because occasionally, something can happen, that one of the antennas goes down or something happens. So you got to monitor the radar to make sure you don't have to reset it or make sure that the observations look right.
That's a lot of hands-on, hands-off, depends on which part of it.
Very hands-on. It's very unique in the numerical weather prediction. There's just not, I don't think there's any other places where this kind of hands-on interaction occurs.
And I think it's interesting because I think as a general public, we think there's dozens and dozens of people that are just all gathered around doing this. But the reality is it's not dozens and dozens of people that are focused on this.
Yes, there is one person on the plane for the radar and one person on the ground processing. For dropsondes, it's typically one person on the ground processing, and of course, the person who's putting the dropsondes into the chute, right? So yeah, it's otherwise, if there was dozens of people with a staff of 15, you couldn't do it.
And you know how the world's waiting with bated breath for that information to get out.
Oh, absolutely. And it's honestly, it's really one of the cool things about it is, like, when I'm on a flight, I'm the very first person in the entire world to see what a dropsonde is showing for a hurricane. And I'll give you an example. Milton, when it was a Category 5, we were having problems with the dropson system. There was some interference with another instrument, and we were trying to figure out why. And our director was processing the sondes and having just a heck of a time making it work. And so I went ahead of him and looked at one of the sondes in the inner core, the radius of maximum winds, and I pulled it up, and that sonde was clean, and it gave me a clue. Okay, here's the problem. But I was the very first person that saw that there was 160 knot winds at 10 meters from this sonde. And that's, you're in a unique position, right? Like nobody else has seen this. So,
do you ever, when you see that, an oh crap moment,
Oh, absolutely.
Like, oh,
I get,
so
we do our meetings. We have meetings on Google Meet. We have all of us on Google Meet. We're all going back and forth. We have this NASA mission tools suite, right? Where I'm chatting live with people on the plane. And so I looked at that RMW sonde, and I looked at the center sonde, and I was ahead of our director, because he was getting behind on processing sondes because of this problem. And so the second I processed the center sonde, I said, hey, I got on chat and I said, here's what the central pressure is. Because they use the central pressure, they send it to the Hurricane Center. At the same time, I texted Dan Brown, which is the Hurricane Specialist Unit Director, and I said, hey, here's what the center sonde shows, just FYI. So we're all going back and forth, letting each other know in real time what's going on.
And then what's amazing is what comes out is this carefully worded statement that just
absolutely. It's chaos in the background.
Fascinating. Let's take our midpoint break and thank our sponsors. We'll come back for more because this is a fascinating conversation. Thank our sponsors who make this a possibility each and every week. USAA, thanks USAA, the South Padre Island Convention and Visitors Bureau, a big part of this. Of course, we're live in South Padre Island every year in the month of April. We'll be back there the first week of April of 2025. Hope you'll be here with us. The Weather Company, Weather Call, Weather Boy, all folks who make these broadcasts and our real in-person conference a possibility each and every week and each and every year. So we appreciate all of them. Hal, let's go back to you for a second. You've got some GeoTrek stuff for us. You've had a fascinating last couple of weeks. What's going on with GeoTrek?
Yeah, I keep going back into Florida. It seems I've been there a bunch of times this year. I was on the ground when Hurricane Helene struck. I actually chose not to be where the eye came ashore. I was in St. Petersburg. It was just such a high impact flood event that we've been talking about, potentially happening for a long time. So I documented Helene in real time, came back to Texas. I went back to Florida in the days after Milton. And so spent a lot of time in Tampa, St. Pete metro area, really understanding the impacts. With that storm, we had a much bigger storm surge in Tampa, St. Pete metro, generally 8 to 9 feet, tens of thousands of homes flooded that have not flooded in recent memory. And then with Milton, what was interesting, I traveled down the coast, and the thing that stands out to me, you expect to see flood and wind impacts. I saw this on the media, but it didn't really hit me until I got on the ground. The tremendous amounts of sand. Milton just pushed in tremendous amounts of sand. Siesta Key, down to Venice, down to Minnesota Key, getting down by Boca Grande. Tremendous amounts of sand pushed into buildings, into homes. I found a building where I could pretty much step on the roof because the sand was 6 feet deep. I'm going to be showing those pictures next week, but really made me wonder, why do some hurricanes push in tremendous amounts of sand and other ones take away a lot of sand and erode the dunes? We're going to be bringing a geomorphologist on the GeoTrek podcast to decipher that. With GeoTrek, we explore the world to tell stories about extreme weather and natural disasters not covered by the mainstream media. If you're interested in those stories, if you want to understand the science and the human impacts behind those events, you can check out the GeoTrek podcast. Episode number 104 aired yesterday. We brought on a really interesting scientist that helped decipher the impact of these two storms. Dr. Jennifer Collins from the University of South Florida in Tampa shared both about the physical and the social impacts. We talked extensively about decision-making, evacuation, really insightful podcast there on the GeoTrek podcast, episode number 104 with Jennifer Collins. You can find that wherever you listen to podcasts, whether Spotify, Apple Podcasts, or just do a web search for GeoTrek podcast. It's a really a episode focused on Helene and Milton. We'll do a second part of that series coming up on our next podcast to talk about all the sand that pushed into these coastal communities.
I'm anxious to hear that because I know I've seen some of the pictures you've already shared, and I'm anxious to see some of those here as well. So thanks, Hal. Fascinating. GeoTrek podcast, if you get a chance to check it out, it's really, really good. Hal, such great questions always, so inquisitive of all the people you run into along the way. I think that's fascinating, Hal.
Thank you, Tim. You know, I have found this combination where I try to just interview local residents and then also bring a scientist on. And so you're getting that scientific perspective, but also the human impacts. We'll see a lot of those in these upcoming podcast episodes.
Terrific. Can't wait to see it. Okay, let's go back to Dr. Sippel. I feel like we're kind of pulling back the curtain on what happens, during a storm, before a storm, after a storm. We're getting some questions, and one of the questions from online, and you mentioned in your daily routine, a meeting you said is open to the public. How does someone go about becoming part of that meeting? That was the discussion, I believe, right?
That's a good. We're going to be doing WebEx this upcoming season, and we announced the meeting. We sent out announcements about it. I don't know how generally the public would access it. We have a lot of university partners from around the nation. I'd say on average, we have 100 or so people on a given call. I don't know. That's a good question. I'll talk to my lab management. I'm sorry, I don't have the answer for you immediately, but maybe it's something we could broadcast more clearly to get the public more engaged. It's the Hurricane Research Division of the Atlantic Oceanographic and Meteorological Laboratory. So our AOML website, maybe we could post something on there. Sorry, I don't have a better answer for you right now.
I sometimes worry that's like one of those things, like once the public got access to the models, all hell broke loose because of both 384-hour GFS, How much of that do you want out there, Because
Sure.
You could be misused pretty easily. Okay, we're getting some questions, and I was going to ask these two about Oscar, this tiny little storm, 6-mile radius for hurricane force winds. Talk about that a little bit, the difficulty, the unique challenges that presented, and is that going to give us any new insight into what we're doing in the future?
Tough storm. I will tell you that we, and prepping for Oscar, like we had conversations with the Hurricane Center about tasking, and they were interested in tasking us to fly it, and Milton literally made me sick. I got sick. I'm still kind of getting over it. It made our director sick, right? So we had two people down, and we were just kind of limping along, and it wasn't the MO we went by with Oscar was, well, if it was going to be a hurricane threat to the Virgin Islands or Puerto Rico, we'll fly it. But otherwise, we're just barely scraping by. And so when it became clear that wasn't going to be a threat, we let it go, and the Air Force continued to fly it. In fact, but I'll be honest, the Air Force was going to fly home. The morning it became a hurricane, that Air Force mission that went into it, that was a scramble. It was a mad dash, because it didn't, from the guidance we had from this is one of the rare times in the Atlantic, at least, where we had no indication almost from guidance that there was going to be, this thing was going to really form. And it went for, I think the best recollection I can have is it reminds me of Umberto up the upper Texas coast in 2007, going back 15 years. It's been that long since I've seen the weather models totally miserably fail so badly to where we just were unprepared with the planes for something like that. And I think part of the problem was it was so small, right? So even our, state-of-the-art new HAVS model, it has a grid point every 2 kilometers, right? So, 2 kilometers, a mile is about 1.6 kilometers. So, these grid points are, it's a fairly high resolution model, but when the hurricane force winds only go out 5 miles from the center, HAVS wasn't enough for this. It was such a small storm. And I think it being a small storm I think that's one of the reasons why we had so many problems with it from the prediction standpoint. It'll be a great research thing to look at in the future. Certainly we need, for our hurricane models, we need to go to higher resolution. And maybe that should help. But it was also problematic that, it's one of these hindsight's 2020. Like if we had had data in the storm, we probably would have had better forecasts of it. But you don't have unlimited resources.
Fascinating. I'll jump back in. I've got more questions coming online, but let me get you back in there because you've got some.
Yeah, I really have two questions. Well, for one, Jason, do you also do data assimilation for satellite data, or is it more like hurricane hunting missions?
So NOAA does do ingest, assimilate the satellite data. Absolutely. We use a ton of satellite data. And so I am not an expert in satellite DA necessarily, but we do have expertise and I will say that hurricanes are an extraordinary challenge for any data assimilation because of how much changes from the inner core to just like the very outside, the periphery of the storm, how the characteristics of the data change so vastly. And so one of our next generation challenges is better using the satellite data, better ingesting that into the models to give a better forecast. We've got a lot of research going on about doing this, and the hints are that the satellite data better use of the data can improve the forecast a lot. So that's our next generation effort.
Jason, a second question. So when you get these pieces of information in real time, like you saw 160 knot winds, I'm curious, where exactly does that piece of information go? Does it go directly to a supercomputer in Miami, in Silver Spring, Maryland? Or like, I'm just wondering, how does the technology flow from where you collect the data?
So I upload the files that I process on my laptop into a web interface. And from that web interface, there's a route that goes to the Hurricane Center where the specialists see it immediately. They see a text message, a text format. And then there's also a message that goes to the Environmental Modeling Center where it's processed and then ingested. Yes, they have supercomputers. They have two machines in different locations that are the primary operational machine and then a backup. And it goes to both of those, and then it will be ingested into the DA systems, data assimilation systems.
Are there any issues with you communicating like from the Hurricane Hunter plane to the ground to people on the ground, either nearby your mission or say at NHC?
Yeah, so we definitely have comms issues that come up, right? So satcom in a hurricane is tough, and so you're relying on a satellite link, and there are times when we lose data transmission, and that's challenging, right? So you try to design your mission so that you have kind of a back end, so that you collect the mission early in the time window for the models, so that if anything happens, anything goes wrong, like you have some kind of back in time to sort out issues and get the data off to where it needs to go before the window closes.
Do you ever notice struggles in communication depending like if you're in a lot of turbulence or anything related to the storm, or is it just more random than that?
It's not random. There's locations that have better satcom than other locations. There's known bad areas. And as far as I haven't noticed in particular in the general area of the storm if it's worse or not. But man, let me tell you, when you're on one of those missions, you're laser focused on what you're doing and not paying attention to what the satcom is doing.
Yeah, no, that makes a lot of sense. Tim, I'll get back to you. Jason, this is fantastic. A great conversation so far this morning.
Yeah, we've got, one of our viewers is asking if there's anything that the general public can do during the off season to help with the research, to help, provide data to whatever. What can they do? Is there anything the general public can do to help with what you do?
The best thing the general public can do is to be aware, right? To know where they live in relation to potential hazards, right? So if they live in a storm surge zone, if they live in an area that floods, right, they need to have evacuation plans that depend on the intensity of the storm and that depend on what their emergency managers are telling them. That's where, if you want to mitigate loss of life, right, you got to have a good forecast. But you also have to have good communication to the general public and action by the public to make sure they take the appropriate action. So as far as like what we're doing on the data gathering, no, I don't think there's really anything they can do. But on their personal awareness of their situation is the most important thing they can do.
Terrific. I think that's a perfect response. Talk about, and you touched on this earlier, but talk a little bit about where we're headed. Switching planes in a few years and things like that. But where do you think? You put all this together, what's our future in hurricane research and analysis?
Yeah, so when we get new planes, we get new instruments, right? And so one of the challenges is going to be to figure out, what instruments do we want to put on the planes? One of the ongoing evaluations is what is the next generation radar going to look like on the C-130s? And then, you make these decisions and you figure out how are you going to use that data? Does it change how you process the data? How you ingest that into the models? How you get the Hurricane Center what they need, right? And then, how do different instruments work together to provide you a more comprehensive view of what's going on in the storm, right? So yeah, that's kind of the next generation. And then the uncrewed systems, absolutely, like that will be crucial, and how we best use this data. And then also, where should we be putting the planes, right? I've been involved in a lot of efforts that evaluate, okay, where are we getting our best bang for our buck? And the similar questions can be asked of the uncrewed systems. And so, all of this works together to provide a better forecast in the end, right? So how do you use the resources you have and you will have in the future to give you a comprehensive view in order to provide a better product?
We in our business, we never want to have surprises. We like to know based on the research where, what's going to happen the next hour, the next 6 hours, the next 12 hours. With Helene and Milton and Oscar, did you have surprises this year? And again, any of those moments when you're going, we didn't expect that to happen.
I'm going to be honest with you. I was so focused on Helene, on the landfall. I saw the forecast, the WPC forecast for what was going to happen in North Carolina, and it just didn't register with me. It didn't register with me how bad it was going to be, until almost it was happening, right? So, and I'm a meteorologist, but I'm so focused on like up until landfall, and where our mission was, which our mission doesn't go past landfall, right? That I didn't see what was going on in the background, right? And that's, so I could see why somebody maybe in the general public would, be so focused on what was going on with the landfall of a Category 4, they may not be fully aware of like how bad the flooding is going to be. So yeah, and honestly, like this is a discussion I've had with my colleagues. Like these floods that happened in North Carolina were once in like 1,000-year events, right? You haven't seen a flood that bad since before people lived there. So how do you communicate? How do you communicate that to somebody who lives there? How bad it's going to be? And that's a real challenge that NOAA is going to, have to evaluate in terms of these really high-end events. Is how do we get people to be aware of really how bad this can be?
I think, and how you talk about this a lot, about how it's just out of our frame of reference. We've never seen it before, and so how do you prepare for a 15-foot storm surge if you don't know what that is? If you just have no reference, it's never happened in your lifetime or the lifetime of your parents. I think the North Carolina floods, the Hurricane Harvey flooding in Houston, things like that, are all these things like that, right, Hal?
Yeah, Tim, something else we found too is knowing your history, but also what we call looking around the neighborhood. So you had people in Tampa saying, hey, we haven't seen a big storm surge in living memory. Well, they've seen it to the south, they've seen it to the north, and the physical geography isn't that much different, right? I gave a talk in January in Alabama, and this was fresh off of my podcast from Hurricane Camille's inland rain in 1969. It's still the deadliest disaster in Virginia's history. This bullseye of 30 inches of rain in the Appalachians. Just in the county where this was the worst, they had 6,000 landslides in 1969. And the point was, look around the neighborhood, and the neighborhood isn't just a circle. It's what areas are physically homogeneous. And so if you're in Western Virginia, the geography isn't that much different than Western North Carolina or the mountains of Pennsylvania. You have that front range there of the Appalachians that take all that moisture. My warning was, from North Carolina to Pennsylvania, you have to consider what happened in Hurricane Camille's rains. I think this concept of looking to your right and left and seeing if there's a neighboring state that has a similar geography that saw a massive storm surge or a massive rain event in the mountains, those bullseye areas can and will shift.
Sure.
Yeah, I think that's fascinating. Just because, yeah, people just don't understand. We don't understand. And one of the things we're going to be doing at the conference in April is talking about communicating that message effectively and finding ways to make sure that you can never make sure, but at least to make our best effort that we communicators communicate that message. And the messages you're giving us, you can go on, you guys can come out and say there's going to be 30 inches of rain as this makes landfall, but unless you've experienced that, you don't know. So it's our job to let people know what that's going to look like, I think. And so it's what you tell us, and we've got to communicate it.
Mm-hmm.
Yeah, for sure. Jason, I had another question for you. You were talking about some of this cutting edge research to drop drones down in the boundary layer and to understand the surface of the ocean, and that ocean atmosphere interaction is so important, but not well understood. Where I live in Galveston, there's a local legend. When the 1900 storm hit on September 8th, 1900, more than 100 people took refuge in a local lighthouse. And so they were there for, I don't know, more than 15 hours. They were surrounded by storm surge. All these people are taking refuge in a lighthouse. And over time, they got really, really thirsty. And so someone walked up the lighthouse stairs with a bucket because they had, water, they had rain coming in from the top of the lighthouse. When they took the bucket up 150 feet and they tasted it, the water was salty. And so it gives this concept that there's so much salt spray, it's probably hard to know where the ocean ends and where the atmosphere begins. I mean, I'm curious what maybe drones or drop suns or technology could understand about this massive salt spray and just the conditions of the atmosphere on the lower level of a hurricane that no one's really, we don't really live through that or understand it.
Yeah, absolutely. This is one of the, I think, key uses of these drones is in order to better understand what's going on, especially in these high-end, intense storms, category 4s and 5s, what's going on in the ocean atmosphere. It is absolutely critical that we understand this better, model the storm, that we and if you better model the storm, you can better predict it, right? But we have just very, very few observations. Drop suns aren't going to cut it because you need sustained observations over a period of time. And the only thing that can really do that is one of these drones. So absolutely, yeah, it's understanding the sea spray issue, but how the friction between the atmosphere and the ocean works is going to be very critical to better predicting the structure of these high-end hurricanes.
Jason, are these hurricane drones built specifically to handle, incredibly strong winds? Is it a customized build?
I think it's a customized build. In fact, we've seen that some of these companies that we've worked with have then been absorbed by DoD or bought out, right? And so that's actually a big challenge, is because they get bought out and then all of a sudden, their product becomes infinitely more expensive and we can't afford it on our budget, right? So we have a company we're working with now that I think is going to be the future of this at a price point that we can work with. And so yeah, they're definitely they have more uses than what we use them for, but they're really useful for us.
I kind of envision, do you do most of your work sitting right there in the kitchen, or can you do it from there?
I can do most of my work in ground-based support. I do the flight planning from here. I do the data processing from here. All of it.
I envision mission control like we see with NASA, or, everybody's gathered in a room with big monitors and you're all right there together and headsets on and talking to each other. It's hard to believe the world we're in now, isn't it?
Google Meet. That's what we use. We use Google Meet to communicate back and forth.
That's awesome. That's awesome. We're coming up to the end of the show. Hal, do you have any last questions you'd like to share or any thoughts?
I mean, this has been amazing. Jason, I really appreciate your openness, like you're sharing all these insights into these operations, but very candid and open about the strengths and weaknesses and opportunities of where we're going. I think it helps all of us understand more about the importance of data assimilation and just what the important job that y'all are doing.
Absolutely.
Well, and I feel the urge to say, okay, tell us a funny story that happens in the middle of a terrible hurricane, but we'll hold off on that for the next show. How about that?
Sounds good.
Jason, thank you. We really appreciate your time today. One of my favorite shows today. Great job. We would just appreciate all your candidness as well. Good stuff. So thank you for being here today. We look forward to having you back and hopefully maybe seeing you in April in South Padre.
Sounds good.
All right, that wraps it up for today. We appreciate it. Hal, Jason, thanks, guys. I want to thank our sponsors who make this show a possibility each and every week: USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, Weather Boy, and Weather Call. We are here each Wednesday, usually at 10 Central. Today was 11 Central. Sometimes we adjust just a little bit. We'll be back next week. Bill Reed will be back with us, hopefully by then. In the meantime, have a terrific week. Thanks, everybody, for being with us. Take care.